Okay, so one of the more common or more popular applications we see of the sine rule and the cosine rule is this idea of a radial survey. Now, when you think of the word radial, what other word in maths does it remind you of? Radius, yeah, exactly right. So the way a radial survey works is, let's say we've got a field that's kind of like irregularly shaped. Okay, so we've got an irregularly shaped field, and we want to survey this field. Well, there's lots of different ways, but one thing a surveyor can do is what's called a radial survey. That's when they go into the middle of the field, they plonk down in the middle of the field a table, and on that table they put a piece of paper, and in the middle of the piece of paper they basically put a pin. And then what they do is, using a compass, they get down nice and low and they look through the pin, they line up the compass, and they look at all of the different corners of the field. And they'll notice what the compass bearing of each of those corners are. And then they'll take out their trundle wheel. I had a trundle wheel in here. I'll be right back. So they take out their trundle wheel and then they go along and they put, in the middle of the field, they put their trundle wheel down and they wheel out to each corner and they measure how far it is from the table to that corner. So then they come away knowing these things. They come away knowing the bearing of each point. So that might be this point over here, coming from our centre, or roughly somewhere in the middle of the paddock. That corner of our field might have had a bearing, say, of 320 degrees. This corner out here might have had a bearing of, say, 70 degrees. This guy down here might have had a bearing of 135 degrees. This guy down here could have had a bearing of, say, 210 degrees. And this guy out here might have been due west at 270 degrees. Then so that was when they laid down and looked at the bearings of each corner of their field. When they then come along with their trundle wheel and measure, they measure this radius, or this radial, okay, because it's coming out from the centre going outwards, are these radial lines. So when they measure the different radial lines, they've got lengths for them. So just randomly picking some numbers here, that might have been 120, that might have been 110, that might have been 135, that guy there could have been 90, and this guy here could have been 105. They're all metres. We've got enough information now to work out the length of each side of our field. Now you're probably thinking, well, why would I want to do that? Well, let's say, for example, that there was along one of the fence lines or one of the edges of the field, there might have been a bit of swampy ground, okay, with the fence running through, and you didn't really want to walk through the swamp to measure how long the fence was there. Okay. There might have been, what other disturbances could there have been? I don't know. Somebody might have tied a tiger. That happens. Happens at my place. Okay. Well, it's going to now. Or just to stop people like you coming along and measure my fences. Okay. So there might be some reason why we don't want to walk across a particular length of fence, so we use a radial survey like this. Okay, so if I wanted to work out the length of this bit of fence over here, what I need to do is I need to know, well, I know this side of my triangle, I know this side of my triangle, and I want to know the third side. That sounds a heck of a lot like the cosine rule. It uses three sides and an angle, right? So I need to find this angle in here. Now look at this. If the bearing here is 210 and the bearing here is 135, can I work out the angle in between them? That's exactly right. So I said, well, just from each other. This is 210 minus 135. What's that give me? 75, yep. So I've got 75 degrees in there. Well, this then gives me the triangle. So if I remove all the other clutter, I end up with this triangle over here. I've got 75 degrees up there. I've got 135 metres there. I've got 110 metres there. And I don't know what this length over here is. Well, that's just a straight up simple cosine rule problem. And the cosine rule says x squared equals a squared plus b squared, 110 squared plus 135 squared minus 2 times 110 times 135 times the cos of the included angle, 75 degrees. So can somebody please do the calculator work for me there? So 110 squared plus 135 squared minus 2 times 110 times 135 times cos 75, and it equals so 22,638. Okay, so that'll do. So x is going to be the square root of that. So 150.4, so that's 150 metres to the nearest metre. Okay, fantastic. So we've just worked out the length of this bit of fence over here. Okay, so how do they make these questions harder? Well, one very common way is they're not going to ask you about this length here, because it's really easy to work out that angle. What they're going to ask you about is this length up here. What's the angle in here? How do I work that out? That's a bit trickier. So this guy's got a bearing of 70 degrees. Well, that means that from north to there is 70 degrees. This guy's got a bearing of 320 degrees. Well, that means from north leaning out to that corner, from 360 leaning out, that's 40 degrees in there. So my angle in the centre is 110 degrees. That's one way they make these harder, by getting you to calculate that angle in the centre there. Sure, okay. So, well, I knew that the bearing of that was 70 degrees because when I laid my compass down, I looked at my compass and it said 70 degrees. Okay, so that said it was 70 degrees up there. That corner was 320 degrees. I just read them straight off my compass. Okay, so literally there were numbers on my compass, I read them straight off. So my question is now, how do I work out the angle in between? Well, that 70 degrees is measured from north. So from north, 70 degrees means that angle there is 70 degrees. Now that angle was 320, but north, remember, is 0, or all the way around is 360. So from 360 to 320, I've gone back 40 degrees. So that entire angle there is 110 degrees. Does that make sense? And so now we just repeat the process using the cosine rule with 110 degrees as our angle. Okay. Now, what about if they wanted to know the area of one of these triangles? Well, that's not a problem. We just use the area formula. In fact, we're going to work out the area of this triangle over here. Okay. So we know that area is a half AB sine C. So area is going to be a half times 105 times 120 times the sine of the angle. Can you do the calculator work for me there, please? A half times 105 times 120 times sine of 110. That's 5,120 square. Sorry, how much? 5,920, my apologies. To the nearest square metre. Okay, that's pretty much it, guys. So we basically use what we know of bearings. We use what we know of the sine rule and the cosine rule if needed, or the cosine rule and the sine rule, sorry, if needed, and the area of a triangle. And these radial survey questions, really, other than that, are just a fancy way to try to hide those formulas, or hide problems that need those formulas. Okay, we've had tons of practice using them. Shouldn't have any practice applying them. It's just a matter of being able to read the question to see exactly what triangle we're looking at, what our angles and our sides are, and which rule we apply. All good? Yes?
How do you get 40 degrees and angle?
Okay, we'll go through that again. So remember I had from north. So north on our compass, remember, is 0, 90, 180, 270, and we come back. So north is both 0 and 360. So north is 360, and that corner of our paddock is at a bearing of 320. The angle in between. Is that okay? Okay, great. So guys, exercise 4I in our textbook is on the radial survey. I guess you apply these ideas. Don't panic. Remember, most of standard mathematics is about your reading comprehension. You'll be fine. You'll be fine. Have a go at that. Thanks, guys.